I'm going to start from the beginning again, just so that everybody knows where they're supposed to be. So I'm at the DCC On Demand link here and going to CHSI R Studio Workshop. This is to launch your Singularity container. Here's the launch screen. You ask for 4 hours, 2 CPUs, HIV R252023, CHSI high, and then this workshop. And then you press the launch button. I'm not going to do that because I already have one. And then after you press the launch button, you should come to a screen that looks like, where is it not showing? Oh, there it is, this one. You should come to a screen that looks like this, and it may take a few minutes, but eventually you should get this blue button here that says connect to RStudio server. And then you want to click on that. And once you do, you should be, this time now, should hopefully be in our project. So if you use this container for anything in between from last session to this session, just make sure that you're in the project. 2022, some I have here. Oh, here it is. Here's the name of the workshop. So this should show in the upper right of your screen, 2023, 2024 HIV workshop. And that way you know you're in the project for the course material. Okay. I've got a bunch of things open, but I'm going to close them for now. Okay. And the first thing I want you to do before we do anything is to pull from the repo. So that's this little down arrow up here in the Git tab. So if you're in environment or history or connections, just go over and click on Git tab. And then you want to go to this blue down arrow and just click that. And it should try to pull. I have already up to date, so, but you should probably see a bunch of verbiage down there. Hopefully no errors. Okay.
It's giving me nothing at all when I click it.
Huh. That's weird. Go to another, click on another. Huh. Okay. You know, if you're comfortable with command line, can you go? Oh, okay. You're not. So yeah. You need to get out of your. Oh, it's doing something now. So what would happen was your container, you lost context to your container. Okay. The network.
All right.
Yes. But is it working now? Oh, okay. Yeah, sometimes what happens with the containers is if you haven't used them a while, haven't tapped them a while, or like possibly a lot of people were all joining at the same time, and so it may have put some of ours to sleep, and now it has to wake up again. So if you got a 502 error, it should come back. Okay, oh, that's from Ching, very good. Okay, so don't forget people on Zoom that there is a TA who's monitoring chat and such, that's Ching, and you can interact directly with her, or you can just ask questions in the chat. You also feel free to turn on your mic and say something, okay? More than happy to hear your voices. In fact, would like to hear your voices. Okay, so hopefully everyone is here. We're in the project, you've done the poll, and you have the updated course materials. If you go into the file menu, and it should be in 2023-2024 HIV workshop here, go down to data science, and then we have a new folder here called visualization. So go into visualization. And the first thing I'm going to do with you today is I'm going to show you some base R graphics. So that people still use them, you'll still see code. And I mean, I still use like at least like histogram, for example, just to like sort of check like what my data looks like. I'll use those really quick things instead of going all the way to ggplot, because it's a lot less typing. If you have a vector and you want a histogram of that, you just type hist, put the vector in there, and that's done. So, all right, so let's look at that, and then hopefully also help you build an appreciation for how powerful and easy to use ggplot is. So basegraphics.rmd, click on that. Don't forget to make yourself a copy. There we go. And underscore capital MINE, because Josh has set that up so that Git will ignore those files. Save. Okay, and I'm going to knit and go to the readable output first.
Question.
There we go. What's that?
Oh, sorry, question. If we're not seeing all of the files from there, I may have pulled, like I pulled it earlier.
Oh yeah, you need to pull again. I probably added files like 15 minutes ago. Yeah, so make sure, even if you pulled earlier today, you should pull again. I changed my mind about things or have an idea at the last minute and I just put it in. So I wanted to see if we might have a little time to cover tables today too after we get done with the plotting.
So I'm trying to pull now, and I don't know if it's working or not. It's double changing the volume around to be overwritten and merged.
Oh, you're getting merged numbers. Does it also say like remove or get dash or something?
Yeah.
Yeah, you're gonna have to get dash.
Okay.
Yeah. If you have something in there that you haven't,
I think everything here has been.
okay. Actually, how do you stash from? I don't even know how to stash from a menu. Just go. What's more? Click on more. Yeah, no. Just go into the terminal down there. This is the terminal of the console.
Okay.
Yeah. And just type get stash. Get space stash.
Get commands on. Get command.
No worries. That. Oh, that's you type get. That's it. CIT. No problem. Is that working?
I mean, yeah, that's fine.
Good. Okay, now go back and pull, and it should work. Is anyone else having trouble pulling the new material from the repo? Anybody on Zoom? Tikan, is that a hand up? I did have trouble, but I got it now. Very good. Tikan, Rana, is that a hand up on your screen, or is that? Oh no, I'm sorry. Never mind. That's not you. Oh, it's the cursor. Great. Okay, so looks like everybody's good on Zoom. You're good.
I'm closing it down and trying to restart it because it won't, every time I pull, it pulls only 1, 2, and 3 and doesn't pull any of the other additions. So I'm just trying again.
Okay. Ching, can you just maybe look up, mind if Ching looks over your shoulder and she might be able to catch it right away. Okay. Just to get it quicker. I have full faith in your ability to troubleshoot it. All right. So before ggplot and all the beautiful tidyverse stuff, there were graphics commands, and they still are in base R. So this is without ggplot. You don't need to load a library or anything. It's part of R when you install it. So here, in this first panel, I'm just setting a seed because I'm going to generate. What that is a seed for the random number generator. And if you don't know what that is, it's essentially a pseudo random number generator. It's a program that generates close enough to random numbers from distributions. And if I didn't do this set.seed here, and it doesn't matter what number you put in here, it's just 1, 2, 3, 4, 5, doesn't matter as long as you keep that number in there, and that's the starter for the random number generator. And what that does is, if you rerun this code, it will give you the same numbers. if you don't set the seed, because it's pseudo-random, it's going to give you a whole other set of numbers. So this is for reproducibility. Although I have to say that I sometimes take advantage of the fact that if I don't set the seed, I get a new set of numbers, because sometimes weird things can happen, and you know, your code works with that seed or that set of numbers, but then if you get another one, it breaks. So so I kind of like the little bit of just testing the other things. And then here, the plot command in base R, plot command generates a two-dimensional plot. And the first argument you give it, it plots on the x-axis, and the second argument plots on the y-axis. So I'm just giving it the sequence 1 through 10 as x and 1 through 10 as y. And as you might think, it gives me a diagonal line because x is equal to y. And this is, and you can see the default labels are 1 to 10 here. I can change the symbols. So by default, I get these circles. I can change the symbols by giving this very, very cryptic, I don't even remember what PCH stands for, but it's an abbreviation for something. And you just have to know what these are, look them up, or just try them to know what PCH2 means. So I can see here, it means triangle. Before looking at that, I wouldn't know, I would not remember. We can also change the, so I can use, so here I'm taking pH 1 to 10. So if I give it a vector, it's going to cycle around that vector for the different characters. And Cx equals 2, I believe that's for the size of the character. So here you see it's a, 1 is a circle, 2 is a triangle, 3 is x, plus, 4 is x, 5 is a diamond, 6 is this upside down triangle, 7 an x with a box, asterisk, and I guess it's a diamond with a box in it, and then a circle. So so those are like a set of the different characters that you can use to put on a plot. You can change colors also. So again, they're numbers. So you don't have the names of the colors. I hope what you're getting away from this is that this is really cryptic looking code, right? I mean, there's a whole lot you need to know. Sorry, there's something in the chat. I'm gonna hold that thought. Yes, so yeah, everyone needs to pull from the repository and make sure that you're in the project, the R project for the course. Okay, so plot 1 to 10, 1 to 10, so the x's and y's are the same. PCH is equal to 3, so I'm getting pluses. I'm setting the size with this, and then colors from 1 to 10. And so this shows the colors that I get. And actually, you can see that there's only, goes black, red, green, blue, aqua, cyan, orange, gray, and that's it. So there are only 8 unique colors. It's very, very rudimentary plotting. I can add text. I can also define how I want my axes to be. So like the limit, so XLM C 0, 11 means I want X to go from 0 to 11. And it's auto detecting Y. And actually the reason that that's done in here is that the J out here, this label is actually going to be off the plot if I don't extend it to the length of 11. And here the text command adds text to the plot. So this is from 1 to 10 plus 1, so that's text is from 1 to 11. To 11 actually. Sorry, that's the X. the X values for which I want to plot the text. Sorry, I keep moving this thing around. Okay, the X values I want to plot from 1 to 11. Y values are from 1 to 10. And then I'm taking the letters from 1 to 10. So if you don't know about this, this is built in. This is a built-in vector of characters in R. Lowercase letters means lowercase letters. So it's, you know, letters of 26 would be Z, lowercase z. If you have uppercase, then that's the letters, uppercase letters from A to Z. Useful sometimes, especially for like labeling a font like that, if you want to have like, you know, A, B, C, D in a figure or something. Okay, and so it's the coordinates of the letter, X and Y, and then what I want to, and notice that it's vectorized, right? So it matches it up. It says, oh, you want things from 1 to 11, you want Y's from 1 to 10, and I'm going to choose the first coordinate for the first letter, second coordinate for the second letter, and so on. So, and also notice that it didn't erase the plot, right? So once I execute a plot command, it keeps adding layers onto it using these other functions. Text is one of them. Okay. To plot a line. So here we're gonna generate a random data set, okay? And the way that you do that is, I don't know how many of you are, somebody wrote, the full name for PCH is plotting character. CEX stands for character expansion ratio. Thank you. I know there's logic to the names. It's just, yeah. Okay, so it was written way back when people didn't want to put a lot of letters into their code. Like when these things were written, I mean, I think Fortran had either 6 or 8 letter limit for a variable name. So that's why you see these really cryptic little things. So I'm going to take a set of n equals 20. So I want 20 points. I'm going to generate the x coordinate by just taking the numbers from 1 to n. And then what this is essentially what your linear models are based on, right? When we say that, when you fit a best line to a scatter plot, in general, you are assuming that there is like some ideal y and x, some correlation between y and x, but then there's some random noise in either measurements or whatever. So so that says y is x, but then there's some random noise associated to it. And if I do R norm without any arguments, just the n, it gives me n numbers from the standard normal. So mean 0, standard deviation 1. Okay, and now we've got, and this is going to be a line plot. So we can say plot x comma y. That's the coordinates. Type is equal to L for line plot. LTY equal to 1. That I believe means line type. So dash, dotted, you know, of whatever you can, dot, dash, whatever those, you know, different line types. Line width is 2, so that's like how wide is the line. Col equal red, so that's color equal red. Main is the title for the main, so it's plot. And you can also give it the labels for X and Y. And then the next, so if I just executed this part, I would just get a line. There would be no points. And then the next command point adds the X and Y data points to the graph. Okay. So I'm just saying what I said before was that the function points adds, just like text, adds to the whatever the current plot is. Until I issue a new plot command, and then it says, oh, okay, now we're going to work on this plot. Here I'm doing a linear fit. So I don't know how many of you done linear fits in R, but LM stands for linear model, and Y tilde X means that I am fitting Y as my response variable and X as my, what is it? I always forget the names of these things. Independent, well, it's independent dependent, but, and then there's response and something. But that's the problem. There's like 5 different names you can use, and 5 different pairs of names, and I mess them up. But let's go with the one that I'm really more comfortable with as a mathematician. We have a dependent variable and an independent variable. So the independent variable is X, dependent variable is Y. And so this generates a fit, and then it's not easy to see what's going on here by just looking at the code itself, because it looks like AB line is just taking the M. It's not clear what M is, what type of object M is from this. So I'm going to show you that in a minute. But I can plot X and Y, color equal blue. So I'm plotting the noisy data I generated, and then adding the best fit line. That's what that is. But this is sort of a little bit of a shortcut. R knows things about M, basically. R is looking at M and saying, what kind of thing are you? Oh, you are the output from a linear fit. So I'm going to extract what I need to put the line in there. Okay. But it's not like it's AB that M is just something for a line. And I'll go through that a little bit later. Okay, we can put multiple plots on the same axes, which are nice. So here I'm making this M again, the same thing, and then plotting the X, Y, and the line. And here I'm generating another set of data. This one where the mean is 10. Sorry, oh no, 10. Sorry, the mean is 0.1 instead of 0. And the standard deviation is still 1. And then plotting those using points, and then AB line for color equal orange. So maybe not the best idea to choose orange and red. It's a little difficult to tell them apart. Probably should have chosen a different color there. But if you square it real close, you can see that there are 2 lines on there. And it's different line types. Oh, and also notice that you can use, so for colors, you can use integers, but you can also spell them out. And line type, you can say dash instead of like whatever 4. It looks like 4 is one of those with dashes and dots. Okay, any questions so far? Gives me a chance to drink a sip of coffee. Okay, moving on. And here's one that I use all the time, histogram. So if I ask for a histogram of Y, it's going to give me this. Now remember that Y is just like, it's flat, right? So it's showing you a uniform distribution. I can break it up, like, well, it looks like, I'm sorry, it looks like a uniform distribution if I give it the default. So the breaks, and when you, I mean, I'm sure you've done this even by hand, you know, when you were in high school or staff class, you would draw a histogram, but you have to choose the bin size, right? And the bin size on a histogram can change a whole lot. So histograms are a little tricky. You can't just take them blind. So if I just type hist of Y and I get this binning, it doesn't tell me anything. Now, if I say I want it to break at 15, that's a little bit better. So now I see a little bit of variation. And then there's a bar plot. So this will take each X and then the Y variable and give the height. The height will be the Y variable and then the X. Okay. So we can also use categorical variables. So here I'm generating, sampling from the numbers 1 to 3. the number is n, so that's 20, that's what we define that to be before, and replace equals t. I don't know who wrote this, I don't think it was me, because I type out true. Also, like, I noticed with the style in some of these too, there should be spaces in between the equal signs for readability. Unless, of course, the shop you're working for says don't put spaces. And then just creating Z, which is just a normal distribution sample of 20. And now I'm going to do box plots on the categorical variable Z. Okay. And so, so you see that there's 1, 2, and 3 because that's what G has, and the median lines are showing here. So that's actually pretty good. And you see it takes the default, then whatever the name of the vector was here, and the name of the other vector here. And also, the other thing to kind of note is this guy's working straight up with, well, I guess the other ones are working straight up with vectors too, but yeah, I don't know. No, scratch that. What happens when you put when you use ggplot is it's a lot more wordy, but you can actually read what's going on. Okay, so you can do quick and dirty box plots. QQ plots. So generate another 100 values, and here's the histogram of X. It looks like, well, it probably should look like it's sort of relatively normal, right? And then you do a QQ plot. So, excuse me. So QQ norm. So what that does is it says, a QQ plot is you take the quartiles of your data set and you compute those, and then you plot I don't want to say quantiles, not quartiles, because quartiles, yeah, quantiles of your data, and then you take the quantiles of the normal distribution and you plot them against each other. So if something was if the data set really is very normal, is close to the normal distribution, then you should see a diagonal line here on points. And the line that's drawn is the one that you want the data points to lie on to assume a normal distribution. And so you can see it's sort of in the middle here, it's pretty good, but on the edges you starts to flake out a little bit. But anyway, but you can get this very, very quickly. And because it's QQ norm, it's actually telling you, like, it has these default titles in it too. So you don't have to worry about, like, and it gives you the normal QQ plot as the title, and the X and Y axes are named accordingly. Now, if I generate, so I generated from the normal distribution, so I really do expect it to be looking pretty normal. But I can also, in R, and in most languages now, you can also generate random numbers from any distribution. So I'm choosing here the gamma. Gamma with shape equal 1, that's an exponential distribution. So, and it means it should look like an exponential curve. You expect to see like a decaying exponential. So, that's the data that I've generated. Now looking at a histogram of it, and you can see that, oops, it looks very much like an exponential curve. Okay. And then if I do the QQ plot, you can see that this looks really bad. It's not along the line here at all, and yeah, there are bits that are okay, and that's because the stuff around 0 kind of looks like, you know, the stuff over the hump of the normal distribution. Okay, you can put multiple plots and place them where you like them to be with base on. I actually find it a little bit harder to do these sort of things with ggplot if it's plots that if it's plots based on the same data frame, there's all kinds of things you can do, and we'll learn about that. But when I have like different types of plots on different data frames, and I want to put them together on a page, then, I mean, maybe there may be a better way to do it, but I'm always using this thing called grid arrange, and it makes me crazy sometimes. So here, this par for parameters, so it's setting the parameter, mf row equals, and then you give it the vector where the first element is the number of rows, the second is the number of columns. So if you give it, 4 plots and you have 2 and 2, then it's going to go 1, 2, 3, 4. So, and they go by column first. Okay. So I'm setting, and by the way, it looks like there's an indent here, but this is a command on itself, right? This is a command it's basically an option setting. So anytime you use plot, once you set that, that's what it's going to expect a 2 by 2. Okay, so plot xy type equal L. And so I created the two different plots using the plot command. And then, sorry, I should just back up. Okay, so this is the first plot, x and y, scatter plot. Second plot is a line plot. That looks crazy. L. Bar plot is equal, bar plot on x looks like this. And bar plot on y looks like this. So it was a 2 by 2, so it filled in the first one, the second one, the third one, and the fourth one. And I find that really, so if you're just doing some really quick, like kind of exploratory stuff, that's not going to go in a report, you just let me see, that's when I would use these. There are people who are very, very, very good at base R plotting and can actually generate really nice plots. So it's possible. It's just, it's a little bit more, elbow grease. So, and here we can save our plots. Here it's basically like, what do they call it? Opening up a stream, I guess is what they call it. So when you type PNG and you give it a file name, PNG says, oh, we're going to write the following output is going to go to the file. We're going to output that. And so it's doing the same thing, right? I'm even doing this, and it doesn't care about this part. But when I get to plot, and then AB line, it generates those as output. And then if I want to continue to see plots interactively, then I have to do dev.off, because if I don't, every plot that I generate is going to go out to this file, and I won't even see it in RStudio. And here you can read the plot back in. I'm not showing the code to do that. That's weird. Oh, well, you can see it. All right, so I've got some exercises for you to do, and what I've done is I have you doing the same exercises in base R, and then we're going to repeat them using ggplot. And so off you go on base R graphics. Anyone who's having trouble with anything, getting files or stuck on something, please let me know. Now would be a good time for me to help out. Did you get everything you needed? You're all good? All right. I'm going to hop out for a second and fill my water, but I'll be right back. Please don't hesitate to ask questions. You have them.
So we're making it this, just the code, like, the AV line, and it doesn't quite do it. So, find it.
Hold on. My computer has gone to sleep. AB line, if you give it M, it should, you have to, M has to be
Okay, right.
the output of a fit. Makes sense? Oh, yeah. And the reason you can't, there's no code showing here for replot back in is because that is actually in the markdown. And this is the knitted document. So if I went back over here, here. Here's the replot in part. This is markdown code. So to read it back in, you have to put that line into your markdown, and then you won't see it until you knit it. Another one of the frustrations I have with our studio, our notebook. Those of you on Zoom, I'd love it if you were finished, if you could put the thumbs up emoji up. That would help me to have an idea of where people are at.
Definitely taking a while. As far as color coding by species, can't find an example of color by some variable.
Yeah, I don't think I did that. Did I do that? Hold on, let's just look. We did color equal 1 to 10, right?
Right.
Did you try color equal? I'm in the wrong.
1 to 3, I don't know if that matches up with the species.
No, did you try color equals species? You probably, since you don't give it a data frame, you probably have to reference it as iris, dollar.
Yeah. Oh, this is okay.
Is that working? See, I don't even remember, but like I just know how R works. That's kind of the best, when you can just sort of guess. It's like, well, how would they do that? Yeah, probably this way. People on Zoom, do you need more time? Can you answer me in the chat? Okay, I think there's a critical mass of people who are done. Does anybody want me to give them a couple more minutes, or can I move on and I'll, cool. All right. I have, and you have it too. Don't look at the JG plot answers yet, though. There, no, not that one, not tables. Sorry. Answers at RMD. if you click on that, and I'm going to knit it. All right, so here's what the knitted output looks like for the answers. So to plot a scatter plot, you just have to give it X and Y, 2 vectors, right? So iris.petal length, iris.petal.width, and you get that. And yeah, and it's kind of cool because it looks like there are a couple of clusters here. Then to add a best fit line, you need to create a linear model object with LM. So you just do that and save it into some variable, whatever you want to call it. M works. I think, I don't know why they use M, probably for slope, but it's not just the slope. Anyways, and then you have to create the plot by using the scatter plot, and then add AB lines with the linear model.
This didn't work for me.
Sure. I will go back.
Okay, well, unless you're missing something, you should order the
It's hard to spot it.
no,
You get it?
apparently if you put links before it in the top section, then you get it. I put this in front of it. You don't get a best fit line.
Oh, right, because your best fit line is for the opposite relationship. Okay. So it actually matters what we discovered. So if you make a model that has iris, lost myself for a second. If you have it petal width as the dependent variable and petal length as the independent variable, then your scatter plot has to have them in the same order as well. So here, like the dependent variable comes first, and then the independent variable second, because it's y tilde x. But here in plot, it's x comma y. So they have to flip around, and it's important that they do. Otherwise, you won't get the line. Okay, good. Create a plot of petal width by species and another box plot of petal length by species, and make these plots side by side. So you want to use set your parameter, excuse me, MF row, and that's 1, 2 for the side by side, and then you just do the 2 box plots. What did I wait? Whoa. All right, yeah, okay, by species, right. So it doesn't actually do them side by side. What am I doing? Oh, I did a 2, 1 here, and then a 1, 2. So I guess I overwrote it. Yeah. What? Yeah. It looks like I overwrote it. Let me go back to the code. Yeah, this should give me what I wanted. Yeah, so that's what it should look like. I don't know why it looks so bad in the other one. There are in the answer file, if you look at it, there are different answers. So that's how you would do it. This is the side by side, 1, 2. One on top of the other is 2, 1. So that's all that's demonstrating. And notice in the end here, we set it to 1, 1. That's back to the default. Okay. All right. Let's go to the next one. Scatter plot of petal width versus length, and color change symbol by species. Okay. there are different ways to do that. I don't think this is necessary, actually. I think all you have to do is this. That should work. PCH, I don't know why we did that. Excuse me, I'm great. Change color or symbol. So I'm just going to change the color. So that works. I don't know if we did this with the new species stuff. That might have been, so if you notice, like, so last year, remember the TAs, who are both staff biostatisticians, gave some of these lectures, and they made some changes. And I guess that's the way that they did this, was to, excuse me, was to create essentially another data frame, I guess. Anyway, you don't have to do that. You just need to say color equals Irish dollar species. It's actually possible that between then and now there was an upgrade, or somewhere along the line, there was an update to R where you actually could use this syntax, because this is how ggplot does it. And I think I see as they kind of like move on, they kind of add new features to old stuff to make that easier as well. Right. So that's nice. So scatter plot, add best lines for each species to this plot. Don't forget to color code the lines. So yeah, so they use a subset command to do this. So first got a linear model for the whole overall thing, and then one that's petal width, petal length for Virginica, one for species, and one for versicolor. And then just plotted those in different colors. And I can execute that. So that works. But if you're at this point where you're making scatter plots and you're wanting to do things, multiple plots over species and stuff, by now you should be in ggplot. Like stop. I wouldn't stop. Don't do this. Straight to ggplot. Okay. And to save it, you just do, like I said, with the dev off, with the PNG, that creates the PNG file. You can also create PDF files this way, by the way. And what's the other formats you can do? Chang, do you know? PDF, PNG, what? JPEG too, right? So any one of those. And that is that. And then this is how you read it in. Of course, that has to be in the markdown, right? You can't have it in the code. So, and you won't see it unless you knit the document. Because that's my beef with our studio, with the way the notebooks work in our studio, is that they don't execute the markdown code. So you just see the markdown like this. You see this, right? And there isn't like a button to say, let me see what this looks like, right? It's just like that. And I don't know if anybody's worked with Jupyter Notebook, which is it was also written for R. It was written for J is for Julia, PY for Python, and then R. And so in that notebook, you have code cells and markdown cells, and you can execute both of them. And so you can see the rendered markdown right in the notebook. And I just like that a bit better, especially for teaching, because I keep having to go back to the HTML. Okay, so that's that. The ggplot exercises are next, and so we're not going to look at those right now. Excuse me. But now we're going to go into ggplot. 3 o'clock. And we can start out, take a break a little bit later. I just need some water first. It's 2:00, yeah. Do you think we need a break?
No, you said 3.
Oh,
That's because the clock.
yes, yes, I filtered it before, but I didn't filter it out yet. I know we're only an hour in. Okay, so, yeah, for this guy, I'm gonna execute it, I'm gonna knit it to get the pretty stuff first. Knit. Oh, of course. Okay. Okay, so I'm sorry, I did that too quickly. Let me go back again. Sorry. Okay, so I'm gonna go to a different file now. I guess I maybe didn't do it too quickly, but it's O2 graphics ggplot2.rmd. And click on that, and then I'm gonna knit so that you can see the pretty output. A little while.
Very dark, so all you gotta do is. I just don't get confused in what you do today. You are.
Okay, so now let's look at what the ggplot does. Of course, to do ggplot, we either have to read in the ggplot library, or be lazy like me and take the whole tidyverse with you. And then there's another thing called Color Brewer, and these give you different like color schemes. So we're gonna look a little bit at that. I know about them, I don't use them. I'm not an expert, so so I won't get into a lot of detail about them. But okay, so first here in the options, I'm setting the plot width and the plot length and the plot length height. Sorry, width and height by default, so I don't have to mess with them individually. So first, we're going to simulate data, setting a seed 5, 4, 3, 2, 1 instead of 1, 2, 3, 4, 5 because variety. Going to take 100, sample of 100, and I'm taking from the uniform distribution. I'm asking for 100 points, and I'm sorting them. And then that's X. So X is a sorted random uniform. And then I'm going to generate Y as a quadratic. So not as a line, but a quadratic relationship as X squared plus X plus 3 plus some random noise that I'm scaling to 0.2. Okay. What do I want to say about this? What kind of model is this? Is it a linear model? It's a trick question. No, it's a linear model because when statisticians speak of linear models, we're talking about the coefficients. So all of the coefficients, there are going to be some coefficients along here, but they are all going to be linear. Right? When you get something like, 1 over alpha or something in your formula, and you're fitting for that. It matters. It's what the thing you're fitting for. We fit for parameters. We don't care what the variables are doing. Okay, so basically, this is a linear model with a self-interaction term, is what I would say. Like X interacts with X. Okay, then I'm going to add another factor variable where I'm just sampling 1 to 4, a length of n, and replace these equals true. So what that means is I'm going to randomly grab numbers from 1 to 4, and each time, like the first time, I'm going to grab a number from 1 to 4. Second one, I'm going to grab a number from 1 to 4. So replace means I don't take it away as a possibility, and that way I can generate this over 100. If I didn't do that, I'd run out after 4. And I want to put this throughout the data set. Okay. And then I'm going to create, so I have this factor, and I'm going to create a tibble, because we're working in tidyverse. And this syntax, I think probably only, but I'm going to point it out anyway. When you create tibbles or lists or whatever, and you're feeding in a vector, you often will see things, this thing that looks redundant, right? It says x equals x. Well, what that means is we are creating a column called x, and we're using the vector that's already been defined, x, to fill in the values. So I can actually change the left-hand side here, and that would just give it a different name, right? Okay. So it's naming and then content, and then printing the data frame. I don't know why this looks so much worse when you render it. I think you probably have to use cable or something like that, because like the print in our markdown for tibbles is kind of terrible. So I think this looks awful. There's probably better ways to do it. Okay. I see more in the chat. Let me check that. Oh, somebody asked that. Maybe I shouldn't have mentioned the thing linear in the parameters, because okay. So GG stands for grammar of graphics. So does anybody know what grammar of graphics is? What makes ggplot special?
You just keep like adding terms to it.
You keep adding terms to it, right? And you add layers, and it also separates certain things out. So so the main ingredients that you need are a data source, which is a data frame or a tibble, preferably a tibble, and a map that maps data elements to visual characteristics. Those are called aesthetics. And for the longest time, before I actually really learned how ggplot worked, I just copied and pasted and put this AES in there and had no idea what it was doing. But really, it's saying I'm going to map a particular variable in my data frame to some element in the visual. So the types of visual elements in plot are called geoms. Okay. So so AES gives me a way to map coordinates to geoms. Layers are added with a plus sign. So it's actually just easy to just kind of write your the code for your plot just as a series of additions. You can do something called faceting, which automatically lets you show groups of plots, right? So if you have a categorical variable and you want to have like linear models, for example, for say species in our data set, you can just use a facet. So if you just add facet onto the plot, and it automatically takes care of everything for you. Scales to control how the mapping is made. So you might like have a log 10 or whatever, and statistics that add summary data to the plot. Sometimes, I'm sorry, I just got distracted by the chat. It was like, yeah. So statistics and geoms are inherently related. Particularly, like for example, for what is it, a bar plot. I think you need to have. You can have counts. If you don't give it counts, it generates like a count as a statistic. So a statistic is a function that summarizes data, and they work together with geoms. And then there are themes, and those define the look and feel of the plot. These are things that I am not expert in. I don't really. I wish I was, because it can make all the difference in communicating. Yes, this would be something that I should really learn more about. But maybe someday. Maybe when I retire, I'll learn how to make pretty plots. Anyways, so the first thing I want you to notice is the ggplot command itself doesn't really do a whole lot. Remember, with plot in base R, you gave it 2 vectors and it automatically made a scatter plot. ggplot, if I just say, okay, hey, ggplot, here's, remember I created this data frame, right, df. Here's a data frame, and then I tell it through the aesthetics command that the x variable is going to be the column x from my data set, and the y variable is going to be the column y from my data set. Okay, so ggplot says, okay, gotcha. You got a plot, and you've got these 2 axes that we're going to map to, and it knows, it looks at the minimum, maximum x, minimum, maximum y, and it creates a grid with axis labels and according to the min and max of the the range of the thing. That's it. That's all it does. Okay, there you go. So in order to get anything on this plot, the next thing you're going to need to do is use a geom. And notice now, like I assigned the output of ggplot to a variable called g0. So g0 is a type ggplot. If I type it on a line by itself and hit enter, it will render the plot. And if I take g0 now and I add on geom point and get g1, I get the scatter plot. Okay. Now, notice I didn't give it geom point any information. I don't have to. So the aesthetics have sort of a hierarchical structure. So when you give them to ggplot, it governs the entire plot. But you can have other statements where you change some characteristics and you do that, or add one on, for example. Maybe I'll add color in a different lines or something like that. And that would be, if I did a geom line and added like colored by some categorical variable, then I would see that in the line, but not necessarily, but I wouldn't see it in the point because it's not over, it's not over the entire plot. If you want an example, I'll give you one later because I think I'm probably being confusing. I can get a best fit line or best fit curve to this model on my plot simply by saying, adding a geom smooth. So geom smooth, I said method equals LM because it's a linear model. And the formula is y tilde polynomial x2. And I don't remember what raw equal true is. I think maybe the data isn't transformed or something. I'm not sure. In any case, I will get this nice curve, and the shade is the 95% percentile. So, and again, like somebody was asking, well, wouldn't this be a curve? And yes, it is a curve. It's not a straight line, but we fit it with LM, the linear model. And that's because really what we're poly x2, that's saying I want a polynomial of second order, which is quadratic. And I want to fit that. And the way that I fit that is I fit it by finding the constant. So it's ax squared plus bx plus c, some constant. That is a generic or general polynomial. A, B, and C, those are the things I'm fitting for. Those are linear. So even though my dependent and independent variable have a nonlinear relationship to them, the methods that I use to obtain A, B, and C pertain to linear models. And that's somewhat confusing for some people. But, you know, I mean, and people only think about it, like, I did this in a, you know, in a 2x2 plot. I'm not sure if people think about it so much when they like go and say, oh, I have a linear model, I have interaction terms, right? X1 and X2 interact. So I now have like a X1 times X2 in the model, right? And it's still a linear model. Yeah. Okay, so there, and just consider the code that we had to do here. We had to define the plot with the aesthetic mappings. We told it to put points on it, and then we also said that we want to want a linear model via geom smooth. And now I create another plot with another layer. I want to take geom point and map the color to Z. So remember, Z is a numerical variable. This is interesting too. Z. Sorry, I'm just looking for here we go. Yeah, so Z is x squared. So Z is a continuous variable. So when I say I want to color by this continuous variable, it's going to notice that. So it's not a factor. So when it colors, it's just going to do it in a range. Okay, so somebody say something? No, okay, so the darker colors, and again, we colored it to be x squared, so it's going to follow that pattern. So that we'll see the dark down here and the light up here, and then it gives us a legend. So we didn't even ask for the legend, it just put it there. We can annotate. So there's a function called labs for labels, and you can see the title, the subtitle, the caption, x coordinate, y coordinate. So now I've labeled, so I've given these labels, x and y. I've given the title with a subtitle, and the caption is down here at the bottom. So really not a whole lot of work to get something like this, I think. And if this is guides, col equals false, that's taking the legend away. If I didn't want to have the legend out there for whatever reason. Oh. Okay. I really have to pay attention to things changing. Just getting old. Okay. So now themes. So there are built-in themes, and then there are ways that you can kind of use theme statements to change appearances without. So theme underscore minimal with no arguments. It is a set of attributes that gives the plot. Minimal, of course. We had the shaded squares in the background and stuff like that, and you can see that those are gone. You can see that those are gone, and it's just a little bit more plain vanilla graph. Theme line draw. That is drawing the lines on the. I think it's just making the grid lines. Oh no, sorry, forgot. Right, lines. Theme line draw. It boxes out the plot. Did you see that, the box on the outside? And it probably changes a few other things, but that's the main feature of it. Theme dark. This could be useful. I know, like, often it just looks ridiculous, but this can be useful depending on like the coloring of your plot. For example, in this plot, if I have this dark plot, I can really see these points a lot better. And these still come out quite well as well. So it's actually probably a little bit easier to see with the dark. No, I don't know if you can sort of adjust the darkness. Probably you can. I just don't know how to do it. I imagine you must be able to, because there must be a dial that says, oh, if it's that dark, it's probably a parameter. And now finally we have faceting. So this is where, so remember we did those two plots for the iris. Well, you can actually use this command called facet wrap and tell it, and give it a categorical variable. So the variable G in our data frame is 1, 2, 3, 4, categorical. So this is, okay, I want to take that map, that plot, the one that we had before, G4, and I add a facet wrap to it on G, and it automatically makes the exact same plot I had, except it separates out by the categorical variable, which I think is really very nice. Facet grid. I don't use this one as much, But it's sort of doing the same thing. It's just kind of, I mean, I would want to do more work to this to make it look better, but it's another way of faceting off the categorical variable. Oh yeah, and you can actually do it like, so this is tilde G in here. If I do G tilde, I can flip it, and this is much easier to read now, right? You wouldn't want it to, you'd never put that even on a slide, right? It just looks ugly. So, yeah, so different ways to facet wrap. Scales. So again, I have built this is G4. So this is, G4 is the plot with, it's got the aesthetics mapped out. It's got the smooth line. And so it's got the points and it's got the line and the fit, right? So that's G4. Oh, actually, no. Okay, right. So I'm doing it here. So I'm kind of showing you everything all together here. So this is GG plot. I give it the aesthetics, add geom point, add the method, the geom smooth, so that gives me the curve with the shadings on it, and I do all the labels, plus, and then facet grid, and then say col equals false, that takes away the little blue thing, and now I end up with these. Okay, so that's basically showing you that you got, excuse me, it's it's essentially what I did before. The colors are a little different. I know that's why, because here I have the color as factor G in the overall aesthetic for the plot. Before I only had it for something else, and it wasn't showing all the different colors. So now I get the colors across the plot. Okay. So this is G4, and this is with the default coloring or whatever like theme I have set up. But there are different color schemes, and so you can use this scale variable to scale by using color brewer. So it goes along the categorical variable, as you can see. So you can barely see the points on the plot. They're there, but it's just really light. And then it moves up to the dark part for 4. So it's kind of, yeah, it's just scaling the lightness and darkness by G. You could do a different type. You scale by sequence and say palette equals red. So it's actually, I think the default was sequence we had already. Type equal qualitative. So that's going to give me a different way of coloring. So the other ones were one color by shade. That's the sequential. Qualitative just gives me different colors. And the palette chooses, like there's different palettes of different kinds of colors. So I chose from palette equal 2. Again, this is something I should really myself get better at. And this is divergent, which basically, to me, I think like a combination of the two. It's scaling the lightness and the darkness, but it's also giving you sort of different colors. So palette equal 2. Yeah, that was orange. Okay. So we have sequential, qualitative, and divergent, different kinds of mappings to color. And display.brewer.all gives you a whole lot of palettes to choose from. And like I said, I almost always just use the default. Some of my software would probably look a lot better if I changed that. So admittedly, I have things to learn as well. Okay, and I'm just saying you can scale by changing the mapping of color, fill, hue, and size, and coordinates and such. So if I want to scale the y coordinate to log values, I just add what? Hold on. That should. Sorry. That doesn't look scaled to me at all. Because those are the same, aren't they? The y values go from 3 to 5. Didn't we do that before? Yeah, okay, yeah, so I have to check that. I don't know why, but that doesn't look right to me. It should be scaling and it's not. Okay, that's an outstanding point I have to deal with later. Okay, so now I'm starting along again, G0 plus G on point. So G0, remember, was just a plot without anything. So it's just telling it what the axes are, what variables I'm going to use, and to map to the geom. So G on point. My cursor doesn't want to work for me anymore. Okay. G on line just creates a line plot. So just remember, G on line is just going to connect your points. It's kind of dumb. It's not doing anything special. The way you get a best fit line is to use the geom smooth with a linear, with some kind of model. It doesn't even have to be a linear model. I think you can use probably you can use the GLM, but you can't. But this line doesn't do anything. I use it like for plotting viral loads, for example, is often useful for that, because you can kind of see that, because they don't do this, right? They kind of go up. Okay, come on. Oh, good, my arrow. Oh, yes, my arrow is working. Very nice. All right. Here's another geom that's kind of pretty. This is geom density, so it's basically plotting a smooth histogram in a way. And I am also creating an aesthetic alpha equal 0.1 for geom density. That's saying how much clarity, how much. Yeah, what's the word for that? How much depth I want in the color, how dark or light I want it to be. Transparency. Ah, thank you. It sets the transparency. And then, of course, I told it to fill on G, so it's doing it by that factor variable. I think this is very pretty plot. I haven't found use for anything that I'm doing, but they are pretty. This is a density, a 2D, so a contour map. Density 2D is a contour map. And then you can do like the rug for the values on the X and Y axes. That's just another geom. Geom bar shows counts by default. So if I say data frame aesthetics X is equal to G, so I'm putting G on the X axis, and then I want a bar plot, and then I'm just saying label some of Y. This yeah, so this is just going to take Y. Sorry, is it summing over it? Yeah, it's going to sum Y over the categorical variable G. I can also give it a weight of Y to sum up over a column by group. Okay, and then if you already have counts, you can just use stat equal identity. So if I have a table here where these Y is a count, like there's 10 here, there's 14, and there's 18 of those, then I can use geom bar, but then I tell it the stat is identity. So in other words, don't do any functions or whatever to the thing, just do that. I filled by X, which is categorical variable now. because it's prettier. Like, I look at, I can't, I don't want to look at that. I don't know. Okay, and here is a box plot. So x is equal to g, the categorical variable. Y is equal to z, that's the, z is the guy on that's going to go on the y-axis. And fill is the categorical variable, z. So I'll get a different color box plot for each. And then I'm, so geom box plot. And then I have this other thing, geom jitter. So what that does is when you have a plot like this, and you ever see a box plot and it looks like there's only like 3 dots on it, but you know there's 15? And that's because they're kind of lying on top of each other. So jitter just moves things around just slightly so that you can actually see that there are more values there. Okay, that was jitter. And then guide fill equals false so that I'm not getting the G like legend over on the side here. Okay. And I can reduce the jitter a little bit by, so before it was 0.2, now I'm making it 0.1. And you should be able to see a difference in the 2 plots. Yeah, but I don't want to stare at that long. But this one is a little less jitter than the other one. Oh, okay. Here's another thing that went defunct. Because jitter is gonna add noise essentially. It's gonna like, so you specify how much noise, you know, the amount of noise that you want, but how much it adds to each is random. So here I was trying to set a seed, but from within jitter, apparently you can't do that anymore. It's probably a different way. So didn't notice that earlier. Sorry. So that didn't do anything. You can, so if you like them, your box plots this way, that's great. Sometimes you have like really long values on the x-axis and you can't read them properly. And then sometimes then it can often be a better idea to flip. And all you have to do to flip the thing is add chord flip. And that just flips X to Y. Okay, and saving plots. Same thing, it's going to be, well, say GG save is bigs box.png. So you can save, so ggplot has its own save. I can't remember, because I always use GG save. I can't remember if you can also use the PNG and PDF. I think you can. I'm pretty sure you can use those as well. But, you know, it has its own, so it's nice. GG save, and you just give it the name of the file, and by the file extension, it knows what type. So here it's a PNG, here I'm saving a PDF, just telling it the file extension. And then there's the save files, and this is the code that you can use to retrieve them in your Markdown. Okay, and now we're going to do the same plots again with with ggplot this time. And I also have a nice ggplot resource that is here for people to look at if they want. Yeah. Kind of fun. Okay. So you are on your own for a bit, but yeah, let me know if there's questions. How much longer do you think you need? What's that? Oh, you're ready. Oh, okay. Okay. Does anybody need more time with this exercise? Okay. Okay, I'll just go straight over to the answers. So a scatter plot of petal width versus petal length. Yeah, it's just, and now we're in tidyverse, right? So we use the pipe. And it's iris, we pipe to ggplot. Aesthetics are petal width versus petal length. And we add down point. And that's all it takes. Okay. And a best fit line to the plot. Geon smooth with method equal LM. And I'm not giving it a formula, right? So method equal LM, I could also give it another argument called formula and specify like I did before with a polynomial. In this case, it's just gonna assume y equals mx plus b. Enter. Okay, and there is the best fit line. Again, with a 95% confidence interval surrounding. Okay. Create a box plot of petal width by species and another box plot of petal length by species. Make these plots sit side by side. Here's just where we do a facet wrap. Oh, I did a little bit more work here, it looks like. I'm not sure you have to do this, but the way I did it was to create a new variable. So basically to pivot longer. So I've got petal length and petal width, right? And I want to create a new column called bars. And it's basically a new categorical variable that indicates whether it's petal width or petal length. So I'll just show you what it looks like. No, execute it. Okay, and so here's a table, here's the new table, and here's the new column. So it says whether it's petal width or petal length, and then it goes by inches. So now I have something I can facet wrap on. That makes sense. Okay. And so I ggplot, x is equal to species, y is equal to inches, because that's a new value column. And then we facet wrap around the variables and jitter. And I'll execute this whole thing. Okay. So those are the two plots. Anybody do anything differently? And got those plots? Okay. All right. I think it's actually a pretty good example of like ggplot likes, and you will hear people say it, ggplot likes long data, right? They want to have like this sort of like an indicator for each so that you can do these faceting and stuff like that. Okay, create a scatter plot of petal width versus length and color change symbol by species. So I just did color. I asked you to do either or, right? You can do both if you want to, but so I did so the X and Y values and then color equals species. And that's that. Okay, and then what? Somebody changed this. Okay. All right, fine. I think they probably, I'm guessing they probably wanted to show that they could save this. And So, but anyway, this is the code that really matters. And so basically because you are coloring by species, ggplot, and you did the aesthetic over the entire plot, right? So anything that gets added to this plot is going to be colored by species. It's going to be split by species. So the points to it, but then also when I add the LM to it, it knows already, oh, okay, I am going to do this within each species. And then to save, we use ggsave. Oh, I see. That's why he did that. I see. Because that's for the next part. Okay. You could have repeated all this code and put something there. Yeah, and then so this is how we save the plot, and then reading it back in again, you're going to do the stuff in the markdown. And create a histogram of petal length and fill the bars by species. So again, that's just you just add fill equal species to the aesthetics, and that will change colors there, and you add geom histogram to get histogram. And you're always going to get this warning with histogram, and you should always pay attention to it because it's saying I'm using a default number of bins, but that might not really be what you need, and you need to be careful about like how your data is distributed, how many bins you should want. I love how you can see like clear changes in species, so it's pretty neat. Okay, and then create box plots of sepal width by species. Again, so box plot, you have the categorical variable. Wait, sorry. Hold on a second. Oh yeah, okay, it flipped it. Okay. I was like, wait a minute, what did I do here? Yeah, so because it said X is equal to sepal width and Y is equal to species, it gives me box plots going horizontally because it knows that it has to separate by the categorical variable. So if Y is species, and then it's going to give me the three things on the species line. Does that make sense? So I was confused. I was like, I normally do that the other way, but yeah, that's great. So it's like a chord. It's basically doing a chord flip itself. So you can see that. And this is more of the same, yes. So we can do a facet wrap, and they look like that. I don't know why I'm not seeing any points on that one. Oh, because I didn't add points. I don't know why there's points on the other one. Oh, those are the outliers. Okay. And then this one is using scale 3x. And I'm not sure I see much of a difference between these two. Oh, right. Okay, okay. So you see what's happening, and so we did a facet wrap, but then it gave us all the species in each one. So when you say free X, it does what you actually want it to do, which is that. I don't know why it does that. Really should figure that out itself. But okay. And this is a great ggplot resource that I put in here. There's a couple of them. Actually have to click on the HTML again. I forgot that. The other one isn't even showing. I can't get to the bottom. I think I have this open in a different window. But yeah, this is under rstatistics.co, and it's top 50 ggplot2 visualizations. And here you can find just a whole list of, yeah, amazing different kinds of plots that you might use. And they're usually pretty darn, yeah, I don't even know what that is. It's a Tusta-styled box plot. Violin plots, population pyramids, and there's many, many, many things you can do, as you can see here. Pie chart, who uses this? Yeah, this is nice. Tree map. Oh, I probably could use that at some point. Yeah. Bar charts, category-wide bar charts. Just, you get the idea. There are many, many things you can do and many ways. And, you know, like, there's a couple of things that I recommend that I often don't do myself. But Google, you know, if you have a particular type of plot that you're thinking of, you can Google around for that. There's another, for people who are at Duke, via the library, there's a service on data visualization and slides and, you know, that kind of stuff. And there's, I don't remember the person's name, but if you go to library services, you should be able to find him on the website. And I think they have like open office hours and things like that you can go. I know for another part of this workshop series of this grant is an internship for the summer. And we usually get this guy in to come and talk about how to put your slides together and what makes a plot a good plot, or any kind of visualization a good visualization. So I highly recommend trying to do that if you're going to be making a lot of plots, because I mean, I know I am personally not good at it. And learning, but there are ways. It's not a talent, right? It's a learned activity, so you can actually go to somebody or take a course or whatever and learn how to visualize data better. So okay, so look at these. There should be another one. It was from yeah, it's not rendering here, but I do have another. Yeah, ggplotbook.org. So it's basically the book about ggplot. So it's another one that you can, and again, these are online and free. So you can look at the whole thing, and it's by Hadley Wickham, of course. Synonymous with modern R. So yeah, so you can learn like tons of stuff about ggplot from here. And now that you kind of know the basics, like what are aesthetics, what are geoms, and whatever, hopefully, and facets and things like that, hopefully you can get something out of this book as well. I'm going to say let's take a break right now. And I have added something I've never done before in this workshop, because we never had time, but because you guys allowed me to go so fast, I have time. So we're going to look at generating pretty tables. And I'm going to use somebody else's stuff for that because I didn't have time to put it together. But yes, I hope it will be useful. Okay, like I said, I got through the material really fast. And so I decided that I wanted to go into a little bit of tables with y'all. And so there actually is a file here in your directory called 04 tables.rmd, and there's not very much in it. It's just this link. And so I've made this little chunk here to load the libraries we might use, and we might want to play around in. But what we're going to do is we're going to follow, this is from the R Markdown Cookbook, so just copy and paste this into your browser, follow the link. And this is, so that, again, the book is the R Markdown Cookbook. So it gives you, yeah, recipes essentially for writing Markdown. This is a function that's in the knitter package called Cable. And then there's another package that I also loaded, I think you might have saw, oh, it's over here, called Cable Extra, that adds on to there. So if I call knitter, I have the cable command, then Cable Extra does a bunch of other stuff. There are other ways, the other programs for a table, for making tables. There's something called format table, which I actually think is very good, but I haven't really used it much myself. I had a student when I was teaching like advanced art classes, a student who said, no, I want to use this. This is so, and she made some really beautiful tables out of it. So I don't want to tell you this is the only package you can use to make pretty tables. There's also something called GT. I don't know much about it either, but there are, you know, if you want to make or learn how to make nice tables, I would encourage you to go out there and look and see what's in the R universe, because there's a lot of stuff out there. Okay, so the function we're going to start out with is it's called table. It is in the knitter package, as I said. And should I make this bigger? I feel like I should. Yeah. Okay. So instead of table is cable, X is what a data frame. And then you give some formats, and these are like ways to, like, the digits, I think that's the number of, that's how to round the elements in the tables and the numerics. Row names, you can pass to the function row names or column names. If they're NA, then they have defaults, like the column names will be the column names from your data frame, for example. Okay, so in here, now he's gonna say that these are, and this is funny, because so if you run this in the console, I think you won't see the table rendered. You'll see this, because what happens is what this is doing, the command, the default is to put out HTML code or markdown code. So this is a markdown table. And so if you execute the markdown, you'll get a much prettier looking thing. So this is just showing you the code that generates the output. And this one is a simple table in HTML, LaTeX, and structured text. So it's not doing the, you know, the bars between the columns. So it's a simple table. And here you can say, okay, I want you to do this, but I want it in HTML, not Markdown. So it gives you the full HTML coding. You can also ask for it in LaTeX. So, and I do this quite a bit, actually, just pull tables into LaTeX documents. So this is, if you're not familiar with LaTeX, LaTeX. If you're not familiar with LaTeX, this is how you code a table. So you have this tabular environment, and you tell it how many columns, whether they're left or right adjusted or whatever. But LaTeX is way beyond our scope, so I won't go into that. But if you use it, it's there. RST, it's another formatting. So all of these are different formats that you can have the output set to. And it is important because there are some features that are limited to, did I say something wrong?
No, I'm sorry. I put in LaTeX to find some more examples.
Oh, and yes.
And then I filled the image, and it doesn't give you, it gives you LaTeX.
Yeah.
It just wasn't what I expected.
Yeah. No, you can't just, you have to, yeah, I know. Okay. It's fun. I like being used to. So there are some things you can do, some tables, functions that you can do with tables that you can only do in certain formats. For example, I might want slider bars on a table because I've got a very long table or a very wide table or both. That only works with HTML, right? You can't if you generate LaTeX code, it won't do that. And it won't do it for a PDF either. Okay. So here's the first thing you can do. You might want to change column names. And this is a nice example because so the Iris data frame, right, it has the petal dot width, petal dot length, right? And it's ugly. Yeah, and it's also really old fashioned. You really shouldn't have dots in names at all. But so here what they do is they say call names, and they're giving it, this is a base R command called gsub. And the syntax is, it's saying, I want you to look for a dot, and anywhere you see a dot, so this is the dot here, I want you to replace it with space, and this is the thing I want you to operate on. So this thing, names of iris, that's the column names of the iris data set. So it just basically, names of iris gives you, oh, let me just show you. Yeah. Oh, got that. Okay. Yeah, so names, iris gives you the names. So it's a vector of these strings. And then, so G sub says, oh, here's this thing. And everywhere in here, I'm going to look for a dot and I'm going to take it out. And the syntax part is for the table is column names. So basically, you can pass a vector of column names to table to replace whatever your names are.
So why is it not calling the virus?
You know, that's a really good question. I think, I mean, column names will work too. I'll show you. And I think it does almost pretty much exactly the same thing. Yeah. So I think they're just synonyms.
Okay.
Or, I don't know, synonyms, I think the right names there. Aliases.
I'm a little confused about just this whole thing. Like HTML is a language, right? Latex and Chrome, I guess, are both languages. It's also simple as an option for making tables. Like what is the?
Yeah, that's a little off, right? It doesn't follow the pattern because simple is really just the.
Just not in a different language. Keep it in R. Is that kind of what that?
I think that can be read as Markdown, probably. Maybe, or maybe it's just R. It's just like what you can see in the R console.
I never used Knitter or Markdown before, so this is all for that. Right? All this table stuff, making tables that look good in a knitted Markdown. Is that kind of
yes.
Use of it? Okay.
Yes. In the end, you're going to knit your R Markdown document. Yeah, so it's yeah, so it's not, because if you did it in here, so I have I did do the thing, right? Cable.
Right, like why instead of just using it?
Yeah, and that's the default is HTML, so that's what you see, right?
But Markdown and like knit are, you know, they read HTML or they read R.
Knitter reads everything.
Right, that's right.
Yeah. I just want to see. No. Yeah, I think you really just have to knit it. But you could also, if you had an HTML document, you could pull it out, but don't do that because that's not reproducible. Okay. Okay. Back to where we were here. Okay, so that's this code is just taking the names from the iris data frame and replacing all the dots with spaces and giving that as the column names to the table that's printing. So, and you can see also that it also prints very nicely when it prints, right? We're only seeing the gross stuff when we do it in there. So that's what that looks like. Yeah, and he's just saying it doesn't have to be from GSub. You just can specify column names like that. They probably have to be the same number of columns as in your data frame that you're trying to put together there. You can give an alignment as well. So LCCRR, that means left, center, center, center. That means left align, center, right. Why are they right centering species? That's funny. Okay, well, whatever. All right, you can add a caption. So just using the caption command, an example of the table caption. And note that, so for me, I always think of captions as below, and there are ways that you can manipulate this, but I would call this a table title, not a caption, but that's me, I guess. But you can manipulate it so it goes below as well. You can use the round function to format your numerics. So you can set the maximum number of decimal spaces via digits, right? And that gets passed to the round function. But you can also just do, this is just how you round, this is how round works essentially, and round and format works, and then saying how it works in when you give these within cable. Okay, so this is just introducing you to those commands. So digits, so if I say round 0, I only get the rounded first place. Digits equal 1, I only get one decimal place. Digits equal 3, I get 3 decimal places. And notice that it rounded up. Right? And then scientific formatting and big mark. That's really funny. A big mark is a comma. Very confusing because in Germany they use periods for the opposite basically. So a comma is a decimal and the period is a, yeah, you can get really easily confused. I can get really easily confused. Okay, so here he's just creating a table, but you can see like these are probably like, you probably don't want this many decimal places here. So this is digits equal 4. That's saying that's the maximum number. So everybody's got a 4, and here, well, you can actually give digits a vector, and you can say first one is 5, the second one is 0 decimal places, and the third one is 2 decimal places. Yeah, so the default is to display an NA. So if you have an NA in there, but you can pass two options. Knitter.cable.na is equal to null. So that just says don't put, so, and then when you see the table, you don't see anything there. You can also change it to ***, so make it whatever you want. So NAs are gonna be, yeah, handled by that. I just wanted to get the idea that you can make very pretty tables pretty easily. Okay. This is nice. This is LaTeX. Although you have to use two, I don't know why you have to use 2 backslashes, but \beta_0 would render that in math mode for LaTeX. So it's interesting how they kind of are putting them together. Yeah. So I don't want to just stand here and read this whole thing to you. I just wanted to give you the idea that this is out there. You can look at things like this, and you know, it's not that hard to make a slightly better looking table than what you get out of how the data frame prints out, and then it does in the markdown file. It looks terrible. So you almost always want to at least pass it through cable if you're gonna knit a markdown file. Does he go into cable extra here at all? Let's see. Text tables, I'm not gonna bother about that. Yeah, this is all LaTeX and HTML. Yeah, so you can, yeah.
Very broadly. When I've only seen R markdown used in explaining packages, and then like in this course, like is that sort of the use of markdown in general, right? Like, I mean, do you use it like presentations and stuff?
Absolutely. You can make slides with an R markdown notebook. And you can, and most of our statisticians are writing their data analysis reports or their SAPs, or statistical analysis plan, in our Markdown and rendering that into a PDF or something like that. So yeah, it's definitely used. I don't think you can use it.
Website?
What's that?
You can turn them into websites.
Yeah, you can turn them, exactly, yes. Yeah. In fact, we used to do that with another workshop we used to run. And there's a program called Sphinx. And if you properly use your header lines, it will use that thing to create a website, and you'll get the whole, like, this is the topic and subtopic, and then the other, yeah, and it makes it really nice. So yeah, there are lots of uses for this. I don't think you could write a paper, but maybe if you rendered.
I'm saying it's sort of what I've been, no, in the paper. So I'm like, okay, So I guess it makes sense for like PowerPoint presentations. You're gonna be talking about code.
Oh yeah.
So just like showing stuff.
Yeah. Yeah. No, so people definitely do that, and it's definitely used in the professional on the stats professional side to make reports. But yeah, journal articles, I'm not sure, because yeah, I wonder if there's a way. That'd be a Josh question. That'd be something Josh would know. I just go over to Overleaf and make a LaTeX document. And then I might have my, R code spit out a LaTeX table that I can copy and paste. Yeah. So anyways. So in addition to the cable package, which the cable function, which is in Knitter, there's also an additional package called Cable Extra. And this guy allows you to do a bunch more things with the tables. He's just telling you how to install it here. Call them all in. And now you have this command called cable styling, and then LaTeX options equal striped. And I guess you get a striped LaTeX table out of that. But here we're looking at book tags equal true, font size equals 8. And so this is the way that, so Cable Extra, hopefully you can see, is a little bit prettier, the table already from what Cable puts out. You have these lines, and it shades in between. It has and so these are sort of a default styling, and then you can give it different things. Here we've only specified font size and took everything else as default.
There is a package called Article, and it'll take your Markdown file and it gives you an option template, and it'll use it'll translate the Markdown file into the template of the journal that you're using.
Oh, that's very cool.
Yeah.
Article.
It's like article.
Ah.
So yeah.
Yeah.
And that doesn't have every journal, but it has a lot of the ones that are.
Yeah. But like plot pathogens.
I'm not sure.
I don't know. No, look at it. Yeah, it's getting more and more like it's hard to keep up because more and more things are happening like every day. And like I said, we're in our work and we're just doing this, and then you wake up and you're like, whoa, what is that? Yeah. All right. Okay. So this is just another example. This you can do all kinds of funny things here. So like it's doing a strikeout here. It's coloring. It's blacking the lines by some row specification. 1 is bold is equal to true. Bold and italic. 2 to 3 is the color is white, background is black. So text color white, but background black. Underline is true, monospace. And then so there's a row specifications and column specifications, and so you can do this. Oh, I like this one. Row specifications, and put this one as angle. I mean, so there's a lot you can really do, right? So I'm basically just showing what's out there and then figuring out how to make a good informative table out of that is an entirely different thing. Yeah, so I would just, I'm not gonna, like I said, I'm not gonna read this whole thing to you. Oh, it's actually 10 to 4. Oh my God, time goes so fast. That's pretty too. Okay, anyways, lots of pretty tables. You can look at this book, and it's a whole book, our Markdown cookbook. And it, like I said, it's online, it's free, like all of these OR books are. So take advantage and look at them. Okay, so we're not gonna do any coding. Right now, what we're gonna do is we're gonna find that QR code. No. Well. All right, so here it is. I think this is the right URL. Just maybe try that one, because I don't think I got one. Did you get another email? No, okay. So hopefully it's that one. And those of you on Zoom, please go to sign in on the sign-in sheet. I think Ching put all of that in. Did you put those in the chat today, Ching? Okay. So just scroll up. I think they're a lot earlier. You know, maybe you could just put them back in again, because there's a lot in the chat. Can you repost them? Great. Okay. Okay, so Ching's gonna put those links in the chat. Please, 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 fill out the survey, and if you could, you know, comments like, too slow, too fast, I really wish you had covered blah, you know, spent too much time on this. I want to know these things. You say them nicely, please, but I mean, I'm looking for real feedback here, not just like, everything's great. Okay. I mean, unless everything's great, in which case, fine. Oh, and while you're doing that, either by messages in the chat or a show of hands, how many of you plan to bring your own data on week 6? Oh, that's great. Okay, can't see Zoom anymore. Are you seeing any hands or anything in the chat? Okay, you're on Zoom, right? Nothing? Okay. Okay. And are they saying bring my own data? Yeah.
Bring our own data, but it's just easier to have that.
Well, there's gonna be 2 of us. Josh and I are both gonna be here. So Josh will do the capstone project, and I will, I will jump off the cliff and hope I land softly. Yeah, so it's either way you want to do it, whatever you think is best for you. So. And again, like I may or may not be able to help you. It depends on what you're working on, but probably I can. Fine. I no longer have any. So Ching, I can't see Zoom anymore, so if anything comes up, please let me know. Okay, so what type of data is okay to bring? Well, definitely not anything with PHI. You can, and the other thing is too, like, if it's a very large data set, then we need to figure out how to get you, so if anybody has a very large data set that they want to bring and use on the DCC, then I need to know about that. Send me an email would be best, because then I have it in writing. And I can, and then I can find out if there is a place that you can put the data. I think probably you can just upload it to the DCC under /work, and I think that's fine. So I can give you instructions on how to do that. And that can even be very large data files, because that's what people do all the time. And then, yeah, but what kind of data? I mean, you know, anything you're trying to do with statistical analysis on. I'm not big on machine learning or networks, so I mean, I think they're great, but I don't know a lot about them, so I probably wouldn't be able to do anything there. Yeah, so, I mean, the best thing you could do is email me and say, I have a data set that looks like, and the questions I'm asking are, and then when I get that, I can try to evaluate whether or not that's something I can help you with. Does that settle it? Does that answer the question? Bring RNA-seq data. If you know roughly how the analysis pipeline should work, and you have questions about, you have maybe bugs in your code you're trying to resolve, I can totally help you with that. I cannot teach you to do a single cell analysis pipeline, because it's just, we have a whole course on that. Like, there's a whole workshop on that alone. I believe we're doing single cell again. But.
So this just have questions about the statistical test if you move.
Oh, in single cell? Yeah, that's a better question for a statistician. I know something about it, but I don't want to, get too deep into that. Yeah, I'm definitely not going to be answering statistical questions. Like, which statistical test should I do on blah? I'm not a statistician, and I should not answer those questions. Ching can probably answer those questions. Richard could definitely answer those questions, because that's his job. Okay, I got that back. Yeah, I'm reading it. I actually got it back on my screen now. I don't know how this works. It's like magic or something. Like, suddenly it's there, suddenly it's back. Any data that needs processing by R. Yeah, sure. So, like, if you say you have multiple spreadsheets and you need to join them, for example, right? Maybe you have demographic data, and then with like patient IDs, and then you have, time series data on those patients, and you need to merge the two together in order to analyze them. I can help you with that. Say you have data that's kind of in a messy format, and not in a tidy format, you need to get it there. I can definitely help you with that. What else? Yeah, basically, if it's any question that has to do with content of that has to do with the kind of themes we're addressing in this course, then that would be an appropriate question to ask.
That's specific to, like, this first section of the course, right? This whole, like, workshop, right?
Yeah.
So, like, that's specific to that, or is later part going to get into, like,
Oh, so that there is a whole series on assays.
right?
Yeah, and there they'll look at like different types of assays and I don't actually know which ones they're doing. I can't imagine that they would skip single cell, because that's so huge right now, and everybody wants to know single cell, except me. Yeah, but definitely the best thing to do about the bring your own data, if you have questions, is email them to me and just explain about what you want to do. And I'll tell you what I can and cannot do for you. So next week I won't be here. It'll be Richard. He's going to talk to you about, I think, experimental design and maybe some statistical tests, something like that. Hypothesis testing, maybe. I don't know. It's not like I don't know anything about statistics. I just don't like to get into the nitty gritties because, like, it's not my field of expertise and it's not what I do every day. And there are people who are way better suited than me. But I can prove the central limit theorem if you want. All right, guys. Well, that looks like it's it. 2:59. Unless anybody has any questions. Nope. Cool. All right. Next week, Richard. And the week after that is bring your own data or capstone.
Thank you.
Oh, thank you, guys.